Hey everyone, welcome to another episode of Into the Bytecode. Today I sat down with my friend Zero Age. Zero Age is the head of protocol development at OpenSea, and this was a conversation about Seaport, the new marketplace protocol they've developed for buying and selling NFTs. Seaport was initially developed by OpenSea as a base layer for their marketplace, but it's now an open project that others are starting to contribute to and build on. Now, before jumping in, I want to give a heads up that this was a technical conversation, definitely more so than previous conversations we've had on this podcast. Zero Age takes us through a tour of the Seaport protocol, talking about how it's architected, how conduits and zones work. We even get into a bit of the low-level gas optimization work they've done on the contracts. So I hope this can be a helpful resource for anyone who's looking to understand the Seaport protocol or anyone who's building with NFTs more broadly. I also consider Zero Age to be a true veteran of the space, and hearing him talk through the design of the protocol can be an educational experience in its own right. I definitely personally found that to be the case. And so with that, I hope you enjoy the conversation.
We could help set a more robust standard for a way of doing this that's not just specific to OpenSea, that everyone could benefit from, because it does seem like there's a proliferation now of interest in creating new marketplaces and designing more tailored experiences, and having something that everyone could use really was an exciting proposition, and something we could use as well. So that's when, once that was all squared away and we were fully on the new version of Wyvern, that's when development efforts really started. We began with making sure that it was efficient and sound from an architectural perspective. And after performing a security review on that and getting the full feature set that we felt Seaport should have all ironed out, then we did a second pass that was geared around optimization. Which
and that's where all the assembly comes in.
Yes. And then Dylan, Keller, and transmissions really just, we descended on these contracts, and that's what a lot of the discussion and narrative has been around Seaport as well. What the hell is happening here? There's a lot of assembly code, but that, I think, is also, when you consider the sheer scale that
you're saving like hundreds of millions of dollars worth of gas or something crazy like that.
If there's any contract where it's justified, this seems like it would be it, and will have important knock-on effects for the entire ecosystem with gas congestion. But it underscores the importance of review, which is why we're running this Code Arena competition with $1 million prize pool right now, going through Friday the 3rd of June. So highly encourage everybody to go and check that out, submit findings.
Totally.
We're very excited about that.
Totally.
And after that wrapped, it's really just review from as many independent parties as we can get our hands on, and feedback from the broader community, as well as educating it on how it works and what the architecture is like, and how there's different mental models for dealing with Seaport than there are with some of these other NFT markets.
Totally. So when you're talking about when you set out to design this, who were you designing this for?
It's designed for everybody. The question of buying and selling NFTs, and more generally moving NFTs around, is a pretty fundamental. And rather than forcing everyone to roll their own solution, which if someone gets compromised, that's bad for everyone. That has trickle through effects to the whole ecosystem if there were to be an incident. And on top of that, there's a real benefit to, if if we as a community in an ecosystem can all agree that it makes sense to be using a shared source of where listings are coming from, being discovered from, then there's so many efficiency gains to be had from that, where you have a much more flexible and composable way of doing this it's not siloed by the particular place where you want to list or
I mean, it's kind of the whole premise of crypto, right? Is to have a shared database and then potentially different views and applications built on top of that, right?
Precisely. Yeah, and it's very much we're still in the earliest stages of this, and it remains to be seen to what extent everyone's going to lean into that. But my hope personally is that we'll all coalesce around something like Seaport to save everybody lots of gas and to make it easier to build with a sort of shared set of primitives that are flexible enough that they can encompass all the various use cases, while also being opinionated enough that from the perspective of users that just want to buy and sell NFTs, that they have an interface they're familiar with, that you're not having to reapprove your tokens all over the place.
Right. That's huge.
Yeah.
In some ways, it makes me think of, I mean, this protocol product relationship is a very interesting one. And I think what's been particularly cool in this case is that you have a long history of data on how people are engaging with the NFT ecosystem at a product level, right? And then you can design a protocol that caters to that. And it's, I mean, I'm familiar with this discussion more in the realm of blockchains and like L1s and L2s, right? Where you design an L1 protocol so that everyone else can get benefit from it. But then, you know, there is potentially something to be said of like, what if you designed the protocol for a more specific use case? Are there gains to be had there? Because you can make specific trade-offs that are useful there. And I mean, I definitely think that NFTs as these like digitally native items that, you know, have the concept of ownership embedded in them is like such a fundamental primitive of this whole new world that we're building, where having a truly decentralized protocol that's flexible, that everyone can contribute to and benefit from, makes a ton of sense.
Yeah. Yeah. One other big benefit of if we can all work together to build a really rock solid primitive that's flexible enough for all these different use cases, then there's nothing stopping us from deploying it across every EVM compatible L2.
Yeah.
Because you're absolutely right that there are going to be L1 and mainnet are, I think that there's a really strong case to be made for NFTs being their origination point being mainnet, because provenance is really a critical aspect of NFTs, and that sense of permanence, and that really gives them the sort of bedrock that a lot of NFT ecosystems are looking for. But then on the flip side, you have users that really just want to be using these NFTs, and especially
which will happen on L2s.
Yeah, and if there's a protocol that can reside on all of these environments, it's still going to be really important to have a good settlement layer that's hyper efficient on L1, because at the end of the day, your Bored Ape lives on L1, and that's where you're going to want to buy and sell it. But at the same time, you've got some cool game that you are transacting all the time with your NFT, or sign-on methods. And I mean, the applications of NFTs is an entirely different discussion and very exciting, but having the same protocol that can live in both environments, and
yeah,
it's, I think, it's going to make building on different environments and different L2s way more of a tractable thing for new entrants.
Yeah. Well, I definitely want to dive into the Seaport architecture.
Yeah, I'm very much excited to talk about the architecture.
Yeah.
So at a high level, first thing to sort of get across, Seaport is a single contract. So the marketplace itself, there's a lot of libraries that are all being used, and the inheritance tree is pretty crazy. But it's all a single contract. And it was not easy to get it to that point. But the idea there is that now you can really leverage in-memory operations. So if you have an architecture that by default is making all of these external calls and has this modular architecture as part of its core, then that's a lot of overhead. Every call is 2,600 gas first time you touch an account. And then you got to do various S loads and what have you, especially if you want those modular pieces to be upgradable. That really adds up quickly. There's also, you're embedding assumptions about the way things are going to work by the way you lay out those modules. A good example would be if you have a module that's geared around calculating what the creator payouts are going to be. Well, now, what if I want to trade NFTs for NFTs, right? There, all of a sudden, some of these modules start to break down, and it's the question is, are they even necessary? The way that Seaport works, single contract, everything happens in memory, meaning I'm an offerer. I want to create a new offer, laying out exactly what items I'm willing to spend, exactly what items I or others need to get back as part of that. And now we can, as the fulfiller that's coming along and says, oh, I would like to take that listing, we can operate entirely in memory and basically spend every offer item and credit every consideration item.
That makes sense.
To give a little more color on the architecture within that high level context.
Yeah.
At the bottom root level, you have a lot of functionality around enforcing EIP 712, which is the sort of base building block of when you want to sign an order. Every order has the exact same structure and syntax that it gives when you sign it.
Yeah.
Which is a pretty powerful concept, honestly. It's, you're going to get a pop-up that actually lists out each offer item or item that you're willing to spend, and you can see it right there. We're also, you can create a MetaMask snap that will actually show the NFTs that are going to be leaving your wallet if it happens, and show the NFTs that you're going to get back, or the tokens that you're going to get back.
Totally.
And we'll list everything out. And then once, so you as the user get to choose exactly what matters to you in terms of what you're spending, what you get back. But then other users, the fulfillers, have a whole range of choices as to how they're actually going to fulfill those orders, as long as all of the conditions are met that were set out originally. So base layer is the rules around that, constructing type hashes and ensuring that the domain is properly applied, all of that. You go up a little further, there's a global concept of a nonce. Now, a nonce is not incremented every time that an order gets fulfilled like you would with a transaction on a nonce is any offerer, any user can call increment nonce at any point and increment their nonce. A lot of users will just leave it at 0. But if you want to bulk cancel all of your listings at once, you increment your nonce. And that's a component of the payload that you saw. So from there, you get into logic around performing various assertions, retrieving information about orders, verifying signatures. Signature verification, there's a few different methods that you can, if you want to create an order, sign an order, and list your NFT, you can always do it directly. So you can call validate and list on chain. This is actually a feature of Wider as well. It's not well understood, but what this effectively does is it says, I'm happy to list this. Don't worry about a signature. It's coming from the origin. But you can also sign ECDSA payload just based on the parameters of all the offer items, consideration, so on and so forth, including 2098. So you can give a compressed signature that's in 64 bytes, which saves us a surprising amount of gas because you lop off a whole word.
Yeah.
And then finally, and this is, I think, a really exciting thing that this design space has not been explored. And I'm really excited to see what the community comes up with around this, is 1271 for signing orders. So like one really compelling use case for this is bulk listings. Rather than just signing a particular listing and saying, okay, I'm happy to sell this NFT. I can create 10 or 100.
Whatever bundle that you want.
Any size that I want, different parameters, prices, expirations, whatever, as long as I'm doing it from a smart wallet. So this is definitely more of a power user feature. You need to pipe things through your wallet. But now I sign a Merkle root containing all of those orders. And then for the signature, I actually supply the proof that the particular order hash is in that Merkle root. So it's honestly just one example. There's a number of very cool things you can do with 1271. Continuing up, you then get into the Executor. So the Executor is, or Executor, Executor is you're effectively going to process through a list of executions or token transfers that are specified by the fulfiller that's calling in and says, here's the orders I want to fulfill. And then it will go through and fire off all of the token transfers either directly. You can always use Seaport directly, give it your token approvals and use it in an isolated context, but you can also use what are called conduits. So this is how we solve for this whole area of upgradability and extensibility of protocol. Nobody wants to build on a protocol where the rules could just change out arbitrarily underneath you. Nobody wants to build on a protocol where they're not in control of the destiny and security of their user base. So anybody can deploy a conduit, and a conduit is really just a place where users can approve tokens, and then Seaport or other marketplaces can instruct the conduit. They tell the conduit to transfer tokens. And the conduit then has an owner. Seaport itself is unowned, unupgradable, hyperstructured, right? Conduits have an owner, a DAO, a multi-sig, whatever makes sense for your trust model and what you as a user prefer. That's a whole debate that what makes sense from an upgradability perspective. Some would bias toward absolute immutability, or maybe just being able to, you seed a conduit by giving it a particular marketplace that it can tell it what to do. But maybe you have a set of guardians that can remove it if there's a problem, sort of like a kill switch. Then on the other side of the equation, you have a whole cohort of users that they actually want a trusted entity or source to ensure that they're staying up to date, give one token approval, and now as this quickly evolving space matures and the ecosystem adapts and evolves, that they don't have to constantly be reapproving, unapproving tokens, and it all just kind of works. Particularly, an ideal steward of a conduit would be someone who really has their ear to the ground, is staying very on top of various developments, ensuring that there's no problems or bugs in the contracts that can call that conduit. And
so the conduit, and sorry to be jumping around a bit, so the user kind of hands a signed bundle of offers to the conduit, and the conduit is responsible for kind of scouring the marketplace, maybe kind of running its own front end.
So the way that it works is that when you create an order, you can optionally specify a conduit. You actually specify a conduit key. This is a pretty cool trick. I'll just we'll geek out for a second. So
let's do it.
Generally, when you want to call a contract, you need to ensure that there is indeed a contract at that address. Because if I call what I think is a contract and it's actually an EOA, just a regular account with no code, I'll get back a success status. Like, I want to transfer you some Ether. I put some data, like a message. Okay, that works. Success. Great. If I thought that was a contract and there was going to be some logic that was executed there, and I'm just going off of that success, then that's a problem. If I thought that was a token and I tell it, transfer this from you to me, and I
so this is where the magic number comes in?
Exactly. Yeah. So what Solidity and Viper do is generally they will actually perform a Xcode size check. They'll say what contract code is there, and if there's none, then they'll revert if you try a high level contract call. Now, what Seaport does is says we can actually skip this entire check. We need to know two things. First, we need to know that there's a contract. Two, we need to know that contract will faithfully execute the token transfers. That's very important. If you could just specify an arbitrary conduit, as an attacker, I could deploy my own conduit, implement the interface, you call it and say, okay, transfer tokens from Cena to 0.
And it just does whatever it wants.
Cool, I did it, and it didn't. So now you can't compose with conduits. So all of the conduits are deployed from a known trusted factory. So they'll all have the exact same implementation. If a conduit is deployed, then we know that it's going to faithfully transfer tokens, or it's going to revert, right? If the caller.
So it does some sort of a check before and after, and make sure that there's like conservation of energy of sorts.
We give the conduit key, which is actually the salt that's used to deploy the conduit via create 2. That means that once we derive that counter,
you know what the code is going to be in there.
The only code that can exist there is the correct code from the conduit that's deployed from the deployer, or it hasn't been deployed yet, in which case we perform the call and we ensure that we got return data back. Because if I call it an EOA, you don't get return data back. So this lets us skip the Xcode size check, shave off a chunk of gas, which is great. And anyway, that's the idea there.
Yeah.
Which I think is a good pattern. And I encourage any developers to think through, especially in cases where you have contracts that you need to know that there's a contract there. Return some data, even if it seems superfluous, because the caller can use that to their advantage to as an efficiency gain.
Right.
And it's just an added assurance that the call worked as intended. I think that's a really good pattern in general.
Yeah.
So yeah, what the executor does is it will aggregate calls to a given conduit as they come in. If you want to transfer tokens, we check and see if they all have the same conduit. And then once we're all done, or if a new conduit is encountered, then we send off all the transfers to the first conduit as part of the batch. We should talk about zones next.
Yeah.
That's the next thing that comes in. So zones The best way to think about zones in their current format is that they give a thumbs up or a thumbs down on if an order is valid. It's like an additional rule set that you can apply on top of a given order. So you have the choice as an offerer, do I want to use a restricted order? And a restricted order can only be fulfilled on the other side if the zone, you give it a call, says, is this a valid order? You give all the order parameters. It also has context on the other orders that were previously included as part of that atomic bundle.
And an order at this point includes both what was offered and the other side of the market, right? It's a complete bundle that will
all
execute.
the offer items, all the consideration items, the particular offerer, all of that. So some simple things that you would see happen with zones, like one really basic type of zone that we'll almost certainly be using right out of the gates with OpenSea is a global possible. Just something that it's literally like, has the whole system been paused? Then don't let this go through. And if not,
wait, a global what? I didn't
pausable.
Pause. Okay.
Another is, you remember we talked about nonces before, that at a very low level, every offerer, every user has their own nonce that they can just cancel everything. What if I don't want to cancel everything? I want to cancel all of my items, all my listings just in this particular collection. That collection can maintain their own zone. And I think this is a really powerful thing. This is like kind of slept on by a lot of people right now as they're reviewing Seaport. Zones give collections, the actual creators, a way to have their own rule sets around their own marketplaces to help keep their community safe, which they're closest to their own community, to add additional functionality and more advanced types of orders based on something that's specific to their own collection. Particularly cool with on-chain NFTs, because you can use those on-chain properties to help dictate. Like if you have an NFT that has dynamic metadata, now I can create orders that are predicated on that dynamic metadata. But that collection, those creators, they could have a per zone nonce. You could have a nonce that's like the creator could increment it and reset the marketplace, for instance.
Right, the creator is running some web application that is generating these offers for the users, and they can in a more sophisticated way increment the nonces, invalidate historic offers, or bake in other sorts of requirements
you can implement blacklists if items are stolen or compromised.
Right.
Or you have bad actors that are trying to.
And this all happens without, it's really just tied to an offer. Like that same user could opt out of this whole system and just create an offer that doesn't include this
100%. Yeah, the offerer chooses what zone they want on their order, what conduit they want on their order. The best way to think about conduits is it's like, this is what the offerer, the user that's creating these listings, is electing to, it's their decision on what trust model they want and how they want to handle their token approvals. So a user would probably be using the same conduit across all of their different orders. Then zones, the best way to think about that is that that's what the user is choosing in the context of this particular type of order.
Right.
Maybe collection specific, maybe like English auctions and interesting like reverse Dutch auction type stuff that's got a non-linear function in terms of how the price curve goes. Those would all tap into they'd have a specific zone that you
wait, so how would you implement an English auction via zones?
So there's a number of ways that you might tap into a zone for something like this, depending on how you want to run the auction.
Yeah.
I think the big thing with English auctions is there's generally a reserve price.
Right.
And the reserve price, depending on how you usually don't want bidders to know what the reserve price is. So
Right.
one thing you can do with zones to help facilitate English auctions, as well as if you're concerned about front run in general, this is another direction you can take, is you can implement commit reveal on the zone.
Interesting.
So you, as a bidder, as a fulfiller of this particular restricted order that's specifying a commit reveal zone, you have to 5 minutes ahead of time, you have to sign a commitment that is still blinded. No one knows exactly what you're committing to, but then you reveal it and you demonstrate, yeah, I wanted to buy this 5 minutes ago. I still want to buy it. And then someone can't step in and or as in the English auction case, you commit to the reserve price.
Right.
Yeah.
Wow, super interesting.
Yeah, zones, I'm telling you, we're just scratching the surface. The pieces here, you don't have to use zones at all if you don't want that modularity, you don't want that extra call. Because as we sort of talked about earlier, Seaport is designed that it could just be one contract. That if what you care about is doing things as cheaply as possible, no need to set a zone at all.
Right.
Last thing a zone can do that is worth mentioning is that a zone can cancel an order. So if you set a zone, another way of thinking about it is that the zone, it's giving a thumbs up, thumbs down, right? But it can give us an explicit thumbs down and cancel an order. Now it's easy enough to create a zone that doesn't.
So wait, so before shifting gears, so just to maybe retrace the layers of the stack, right? So at the very bottom, there is like signature kind of checking logic, right? Mm-hmm. Then on top of that, there's this concept of a nonce, which is set by a user who's creating an offer. Yep. And these nonces don't
let them bulk cancel by incrementing that nonce at their leisure,
as they want. And then the user has this ability to create an offer, and they can sign multiple offers at the same time using this EIP 1271 bulk listings. Mm-hmm. And each offer will both point to a particular conduit optionally, or just like the top level Seaport contract as its conduit. And I imagine that each offer will also specify a zone optionally that it kind of complies to.
Precisely.
Then these offers are handed over to this Executor contract, which
this contract is basically just, you can think of it like middleware, like plumbing, right? All of the tokens remain custodied by the offerer or the fulfiller, and it's only the offerer gives an order that says, as long as these very specific conditions are upheld,
right?
Then that are
you have the permissions to do this transfer.
Then we can move the tokens directly to the fulfiller, and
that makes sense.
The fulfiller to the offer, which is, I think, a very, very important distinction to make. That this is entirely a system where offerers choose the terms that matter to them and under what conditions they would be willing to spend items and let them leave their wallet. Namely, it's generally that they're getting something back, and fulfillers then have full choice as to which of those they're going to actually do.
It's really only signatures that are changing hands, and permissions, like an offerer has given a particular conduit permissions to do a particular transfer. Right, so these conduits come back with a list of potentially successful trades to happen. and and then at some point here, the zones also come in as a final check. So I don't know if it would be the conduit that's doing that check, or it's the executor before doing all the transfers, and then the system settles, basically.
We've sort of begun at the base layer of, all right, you need to be able to sign and construct and sign a valid listing, right?
Right.
And then we also talked about the very last step, which is, okay, we now have this set of executions. Let's go and tell the correct conduit in one bulk set of transfers. Like, here's what you got to do, and the conduit will do it. And that leaves this whole middle ground now of, all right, well, what about from the fulfiller's perspective? So we've created these orders.
Right.
We know how the orders will be executed, but how do we get from A to Z here? And that's where we get into all the different methods for fulfillment. So a fulfiller, they have a range of choices depending on the type of order and how many orders and all of that. In the most simple case, which I think we should start with, is in the order fulfiller is the library that it is using. The simplest case is just to call fulfill order. When you call fulfill order, you're actually creating a second order, an implied mirror order of the one that you're fulfilling, where every item that's being offered on my second implied listing or order, I'm just going to say, I'll take all of those offer items and set them as consideration items with me as the recipient. Then on the consideration side, I just look at all of the consideration items in my implied order. I'm going to create an offer item and pay out each of those myself. So this is the most basic standard way that you would fulfill a specific order. You discover that order, you call fulfill order. There's a few important downsides to doing it that way if there are other routes available. One is that consider the case where you are making an offer to purchase an NFT. So you own a cool cat, all right? I put out an offer on your cool cat to buy it for 10 WETH. Now you want to accept that. So you call fulfill order. You now create a mirror that, and you can also specify a conduit as the fulfiller as well. You have that full flexibility, but you create a mirror order now that says, all right, you are offering to give me 10 WETH. Your consideration items are going to be this cool cat goes to 0age. Call it 0.25 WETH goes to OpenSea, and 0.1 WETH goes to Cool Cat's creator. So now, what would happen practically here is you create the mirror order of that, and you now are offering your cool cat. You're also offering WETH to OpenSea and offering WETH to cool cats, and then you get back WETH as well. That means you have to have WETH approved as well, and that there's a possibility of redundant transfers. So there's another method that's called, it also has a lot more call data than you necessarily need in these simple cases, like the hot paths, which are effectively just buying and selling a single NFT, and you have ETH and ERC20. Basically the fallback case of what is the standard behavior on other NFT marketplaces, right?
Right.
And that is still a very common use case. So for these, there's this method of order fulfillment called basic fulfillment, or you call fulfill basic order. What that lets you do, you pass in a subset of parameters that it cuts down on call data. We can do a number of tricks where we don't need to validate quite as much information about what's happening. And we can transfer, like in this accept offer case, we could just source that WETH directly from you, the original offer, and you pay out to your own consideration items, and then just give the remainder to me, the fulfiller, who's giving you the NFT. If that makes sense. So that cuts down on some additional overhead.
Right.
The fulfill basic order method is pretty cool as if you're reviewing the contracts, because it is so heavily optimized. I would encourage people to check it out.
What's cool about it in terms of the optimizations?
Just lots of branchless logic in place of conditionals. Jumps are relatively expensive, particularly like loops through stuff. If you can replace that with logical operations, it cuts down on overhead. And I think probably the biggest optimization is in the way that we are deriving the order hash. So you have this whole EIP 712 payload that particularly because you have arrays inside, you have the offer and the consideration, which are both arrays. The derivation of that in a naive format is quite inefficient, where you actually have to include a type hash for each struct in that array, and then you have to hash each item.
Right.
And then you have to concatenate all the hashes. You have to hash that, and that is what you actually end up providing. So what we do is we read directly from call data. We know that there's going to be, given the size and the type of the order, we know exactly that there's going to be only one offer item. That's a requirement of basic fulfillment.
Because it's a basic fulfillment.
And we know that the consideration items, there's going to be consistency. Like if you're taking fees and ERC20 tokens, like all the consideration items beyond the first one are going to be considered, are going to be that same ERC20 token, things like that.
So you kind of know the shape of the call data ahead of time.
We know,
and you
exactly
can kind of slice the bytecode in a particular way.
So what we do is we ensure that the encoding that's passed in to that call is standard. You can do unconventional encoding in with like the ABI encoding, because a lot of arrays and dynamic bytes, they actually have pointers that tell you, okay, go look at this section of call data. That's where the data starts, and then it has a length that's like the head of what's
right. Yeah.
Data. You could do weird stuff, like say I have two duplicate arrays, I could actually just pass in the same pointer for both, and they don't actually both need data.
Instead of like rewriting it a second time.
Yeah, so there's all kinds of unconventional ways you can do this, but we basically say, no, you have to use the conventional standard encoding for this particular call that you would get from any library that you're not doing something funky under the hood. So we ensure that that's the case, and then we can use fixed call data offsets and memory offsets. Every single time, if you're working with like a free memory pointer and dynamic call data that you can't, it's not always immediately clear where those like the offerer is always going to be in the same place, the zone is always going to be in the same place, that kind of thing. Then you have to use that pointer, you have to add to the free memory pointer, copy in. You have a lot of redundant copies in memory, particularly on the hashing side. So what we do is we basically just say, go to this exact specific offset of call data, put it in this exact specific offset of memory. Do that, copy this whole region of call data into this region of memory.
Wow.
And then reuse whatever sections we can. So like, oh, well, we just calculated this particular consideration item's hash, and we know that these fields haven't changed, including the type hash and whatever. So we're just going to put in the new fields, reuse that same memory region, get another hash. And we also, like, as we're going through the loop, we're preparing the event data at the same time. So, because on the order, you're actually specifying the order item or the consideration. Those have a start and end amount. attached to them, which if the order is like, depending on when it's fulfilled, there's a linear fit that's applied. So you can do ascending and descending amounts. But when you're actually looking at the event or the execution, you just have, all you care about is what was the actual spent amount or the actual received amount,
Right.
or the realized amount. So we have to do some kind, we transform the type a little bit on the way in and the way out. So we create all of that as we're going. All of this is to say, basic order fulfillment is heavily optimized. Very
Crazy.
excited to.
It makes me think of it's like what it takes to write a compiler, you know, with like JITs and like just you're fully just in the bytecode, moving things around between, you know, in that case it would be between different stack locations and whatnot.
Oh, I have immense respect for compiler devs. It is a truly mammoth challenge, and they just crush it.
Is there some crossover in skill sets? Like, are compiler developers a good fit for writing very optimized Solidity contracts? Because to me, it feels like it's basically the same kind of work, except applied to more of an application level domain.
Yeah, I think that there's huge crossover in skill sets. Understanding the EVM at a very low level and knowing the shortcuts that you can take given certain constraints that you couldn't take in a generic way. Like if you're just accepting, memory management is a fantastic example of this, right? So the example I gave for reusing memory regions is assuming that we know that this particular region of memory can be reused. These fields are consistent across them.
Right.
The compiler can't really know that unless you can instruct it somehow of that. So what compilers will do effectively right now is that they will just allocate new memory and then copy the existing stuff that it needs to over into that and operate on that region of memory. So there's a lot of redundant copies and unnecessary memory expansion, but it's also somewhat unavoidable if you're going to be operating in a way that's safe and memory safe for whatever you throw at it. One thing that I found pretty interesting about Viper, as the learning more about it in the Viper working group on Seaport, is that Viper takes a slightly different approach than Solidity, where it actually allocates static regions of memory. And that definitely makes it more memory safe in many ways, at the expense of capping the size of memory that you can use in that region. So I think it's a pretty cool different paradigm, though arguably, depending on whether or not you need really big or really small memory, depending, I could see that being more problematic.
Do you gas optimization at this level? It feels like it's only going to become more and more relevant if you're deploying something on mainnet, especially as the block space is like eaten up by rollups and there's more and more adoption. And I think you're right in that certain things, at least for the foreseeable future, will continue to settle on mainnet, or even if there are L2 centric protocols, they might anchor onto mainnet in some way.
Yeah.
So
First thing I would say, everyone understands that gas optimization is going to become increasingly important in the mainnet context, right? What I don't think people quite understand is that gas optimization is going to be equally important in an L2 context, because it's like that analogy of you build more lanes on the freeway and now there's more cars driving.
Yeah.
If these things are going to grow and scale out, then you want the bottleneck to be on the number of people that can be using it, and not on the efficiency of the stuff that's running on it.
And because they're anchoring onto, because they're using mainnet as a data availability layer, at least currently, the scaling gains are only linear, right? But why do you think, I mean, why is this different than how the internet evolved? Like at this point, we don't really care about how much, like we're not optimizing our web apps, even though they use bandwidth between all of these server client calls and whatnot.
Well, if every time I visited a website, it caused the website you were visiting to load a bit slower, then I think we would be optimizing for that.
It's true.
Right? It's a shared resource. Now, I do think it's important to take a step back because there are places where it makes sense to optimize for gas. If you do it, it's really important that you are highly considerate and that you really take the time to document exactly what's happening, to understand what's happening at a low level, and to get as many people to review it as possible. Not just talk to me. Hit me up if you're doing something with Optimize. I will do my best to connect you to whoever I can and we'll help review. But it's also
that trade-off of like how easy to understand the code is like a very important one when it comes to security, right? Of like all bugs are shallow when there's with enough eyes on them. Like you don't really get that if no one can understand what the hell they're looking at.
I think it's very important that more people understand assembly because it's going to be a value additive, even if we're not writing more assembly collectively, for everyone to understand at a lower level how these things work and to be able to review the assembly that is written. And yeah, so I think it's really critical that we all level up in our understanding of this low level behavior of the EVM if we're going to be building on it. That being said, it's really important to take a step back and ask what needs to be optimized, what doesn't need to be optimized, right? We made the conscious design decision with Seaport that, okay, deploying Seaport, right? Deploying new conduits, changing ownership of conduits, like transferring ownership. These are not things that need to be gas optimized.
They don't happen that frequently.
Yes, what matters is having additional assurances and security checks. Before you have product market fit, spending cycles on gas optimization is probably not ideal, right? Like ensure that it's something that people want to use. And lastly, don't even begin thinking about gas optimization until you have a full test suite and a complete protocol. It's so easy, and I'm speaking from personal experience here. It's so easy to get tunnel vision and just focus on making that one route a little cheaper before you have all of the pieces in place, and it's just distracting from the core objectives. And besides, you can iterate with more confidence once you have a comprehensive test suite that you can run. And finally, I do think that the biggest gas optimizations are not necessarily going to come from porting to a different language or using assembly or whatever. It's examining the assumptions that you're making. What can we do off-chain versus on-chain? Great example of Seaport is we started out being like, okay, here's a number of orders. Let's derive the optimal set of fulfillments on chain. And it was like, yeah, cool. This is awesome. But we just spent more gas deriving the optimal fulfillments than we would have saved by just making all the transfers in a naive fashion. And another really interesting thing about this is if you have a like the way we've been talking about the order fulfiller and basic order fulfiller, which are the sort of standard methods. This is actually a great segue into the other types of fulfillment. So you got the mirror, just fulfill order and fulfill basic order, which are effectively taking a mirror. Basic order does has some extra juice that
Yeah.
is just
You're
really
taking a single individual offer, you're mirroring it, you're adding your own consideration items into it and a recipient, and it just executes because it's pretty straightforward.
exactly. It's
Yeah.
pretty straightforward. So we've talked at length about the basic primitives of you want to create a listing and you want to fulfill a listing. But now I want to get into what about if you have multiple listings that you fulfill? And then I think we should also talk about some of the interesting additional tools in the tool belt in terms of what you can specify for specific items. But first, let's talk about the order combiner. So this is near the very top of the inheritance tree. The order combiner implements a series of functions. First, we'll talk about fulfill available orders. Fulfill available orders, this is effectively, you want to sweep the floor. You want to buy a number of NFTs in one shot. Now, the way that this is handled by most aggregators today is that it's like a multi-call. It does it in a loop. It will fulfill each order according to whatever the logic on that marketplace and perform all of the transfers for each of them. What this requires, though, is that as the fulfiller that's calling these, that you have to catch any errors that happen and you have to perform all of the transfers. And sometimes those errors happen pretty late in the chain of command. Like it's not until you actually get to transfer the tokens that it all breaks or something to that effect.
Right. Like you realize that the person no longer owns the tokens.
Something
like that. Yeah.
What Seaport enables is the standard case here is that I'm trying to buy an NFT, someone else has already bought it. That's really the number one failure case, especially you have a brand new NFT that's just dropped and it's first time people are trading it in secondary markets. So what you can do is you can give a whole list of orders in the order that you want them to be attempted to be fulfilled. And it will go through and it will check and say, has this order already been filled? Has this order been canceled? Has this order expired? If any of those things are true, we'll just pop it off the list. Skip this order. And then we're just going to take whatever is remaining up to a maximum fulfilled. So if everyone's kind of trying to buy the same floor NFTs, then rather than just, I want to buy 5, I'll give 5. Someone else is probably going to do the same thing. You can give 10 or 15 or as many as you like, so that if those first 5 are taken, then you do the next 5, that kind of thing. But you're going to stop once you get to 5. And so you can specify, I want to fulfill all of these at once. And then you can do it as one big batch. But effectively, you're creating a mirror order for each.
Got it. I would be curious to talk through when a user comes to use OpenSea, the website, right? Like I either list or I'm buying an NFT. What is the actual like flow that's happening through all of this? I think it would just help with like understanding it to talk through the life cycle and actual trade going through.
So when you go to OpenSea, if you want to list an item, you pretty much OpenSea is just going to, it's like a set of tools that it's going to make it easy and presentable to construct a Seaport listing and sign it, present the interface in a trusted context, a domain that you can have strong assurances that you're going to be served the payload that you intend to sign. The good news too is that there's even additional assurances now that the payload itself is much more parsable. The domain is part of the 712 specification and you can see exactly what you're signing. But that's on the creation side. On the fulfillment side, OpenSea is basically just indexing what's available and helping users to discover what is out there, particularly in the context of these are the NFTs that I own. And so I'm curious what listings and offers are relevant to these NFTs, or the NFTs that I'm interested in buying. Are the listings available for these? So it's facilitating discovery, and then once that discovery has taken place and the fulfiller decides they want to buy or sell, then at that point it's sort of the same premise where OpenSea just sort of provides the tools for you to affect that transaction yourself.
Right.
And at that point, you actually don't even need OpenSea. It's really you're submitting it directly to Seaport at that point.
Right.
So yeah, OpenSea it's more serving this role of discovery and
A trusted tool for
trusted.
like generating these signatures and basically viewing the protocol layer data.
That's right.
And so OpenSea has a fee, right? Has a 2.5% fee. Where does that come in?
Whenever you are dealing with Seaport,
Right.
Seaport does not have any notion of fees as part of the protocol. But the way that Seaport represents fees is via consideration items. So you just name additional consideration items with the recipient being whoever the fee is going to go to. And this actually, there's a really interesting feature on Seaport that we call tipping. When you originally create an order, it has some number of consideration items. Could even have none, right? Like I could just offer something that's effectively like a donation, right? You could also create something that's just a consideration item and no offer. And that's like, I'm asking you to give me this, or you get the idea. But like you create an order that has a certain number of consideration items. Now, as the fulfiller, every one of those consideration items must be received back by the recipient. However, there's no requirement that you can't add additional consideration items. You can tack on the tip. And this enables the fulfiller, might be in an entirely different domain than where the order was originally created, can apply their own tips. And you can extend this in a powerful way with zones too, because the zone, that is a restricted order, can now examine the consideration items, which can be dynamically set at the time that the order is created via tips. But it can then apply the rules at once, like, oh, I want to validate that this tip is in line with whatever custom rule set around how this tip should be applied. Maybe the creator wants to be able to update their recipient address. And so then you can check that at the time of order fulfillment, supply that as a tip, zone makes sure that it's up to date.
Got it. So like OpenSea, the website, and the company that's interfacing with Seaport, the open protocol, the way OpenSea makes money here is when an order is fulfilled, if it's being fulfilled via the OpenSea UI, it will tack on an additional tip that goes to OpenSea itself.
The way that things will be structured, at least at first, is that when you create an order on OpenSea, that a consideration item will be added. Yeah.
That makes sense. I mean, you want to, even from a protocol design point of view or from an ecosystem design point of view, you want to incentivize both the third parties who are a source of like offers being created and the third parties who are a source of like fulfillments happening. You want both of them to be incentivized, right? So whether it's OpenSea or it's, let's say there's a smart wallet that allows people to directly trade NFTs in there, you can, when you create an offer for a particular user, you could include an additional consideration item which pays out the wallet creators, for example.
Exactly. And that way it just gives a lot more flexibility, and I think will encourage different kinds of business model that can cater to specific types of user. That,
Yeah.
while everyone can still benefit from shared liquidity. So if you're more comfortable using a site like OpenSea, then that doesn't preclude you from also being able to view and create listings.
Totally.
Another site could easily, by building on top of the same Seaport protocol, now they're all broadly compatible.
Yeah. Awesome. So maybe quickly recapping all the different pieces of this. So there's ERC 1271 bulk listings. There's this idea of consideration items, tips, which allows a lot of flexibility in additional, in third parties, like being involved in how these offers and fulfillments are entering the kind of like decentralized protocol. There's this notion of conduits, which are basically responsible for holding all your permissions and figuring out successful kind of trades that could go through. There's this concept of zones, which can be used in different ways to as a final kind of Boolean check on whether a completed order can actually like execute. And there's also the fact that fulfillments don't need to basically happen in this one-to-one way. They don't need to fulfill just like one particular offer. They can, you can fulfill multiple offers as long as the global kind of like mapping of them all checks out. So if I didn't,
that is a good overview. The two pieces that I want to touch on next that we still haven't gone into the nitty gritty on are criteria-based items and partial fills. Both juicy topics. We'll start with criteria. You can always name a specific token ID or identifier that you're interested in. I want to buy Bored Ape 1, 2, 3, 4. But one thing that users are really asking for, and that is a popular idea that's gaining traction, is that, well, I'm actually okay to buy any number of Bored Apes, any Bored Ape with an astronaut costume, or any Bored Ape period, collection level and trait level offers. So criteria-based items enable you to do that on the offer or the consideration side. And the way it works is that instead of giving a token ID that you care about, you give a Merkle root that contains all the token IDs. Then the fulfiller provides, during fulfillment, they choose what token ID they want and give a proof alongside. Then you can prove that that token ID is contained inside that Merkle root and resolve that criteria-based item into just a standard item. There is a limitation with the current version of Seaport where you can only resolve a specific item once as part of any single order, which then ties in very nicely though to partial fills. Just like you can choose whether or not an order is a restricted order and needs to check a zone to see if an additional rule set is adhered to, you can also specify that a given listing has partial fill support. The way that partial fills work is that every single offer item and every single consideration item can be scaled down, as long as they're scaled down by the same fixed amount. That a fraction that's given when the way that you do criteria-based and partial fills is you call the advanced version of whatever the function is. So there's fulfill orders, there's fulfill advanced orders, there's match orders, there's match advanced orders, right? Fulfill available orders, fulfill available advanced orders. And in those, you actually get a numerator and a denominator for each order saying, this is the fraction I want to fill. And you can also give criteria results. So the only rule with partial fills is basically that everything needs to exactly scale down. So if there's any remainder after applying those fractions, it's not going to work. So the way that you structure that, if you're trying to build something that does partial fills, is you start with what's the unit piece of this, and then you apply some number on top of that. So if I had 10 1155s that I was trying to sell, I would start with what's the price for just selling one of them, and then I multiply both the offer and the
right. By 10. Like you're not gonna fractionalize any NFTs or anything like that. They're gonna remain in whole numbers.
Yes, NFTs are non-fungible, as the kids say. Another interesting point of intersection is with, and we touched on this earlier, ascending and descending amounts. You can have a start amount and an end amount for any item, and from the time that the order's start time and end time, you just find the linear fit and apply that. The way this intersects with partial fills is that you apply the partial fill amount to both the start and the end amount, and then it will apply the linear fit from there. So
wow,
that's pretty much that's the
crazy
grab bag of features.
So basically, with the criteria-based offers, you have a lot of expressiveness in what you request as a consideration, right? And so you can, I mean, if you can put a Merkle root on there, you can basically make that Merkle root include whatever leaves that you wanted. So you get full expressiveness in like what you'll accept in return for this offer.
It's also pretty cool because you can then, particularly if you're leveraging contracts with 1271, you can build primitives where you actually can have oracles for floor prices, because you can say, look, here is a standing collection level bid with this price that any holder of this NFT can leverage. So now I can take that and actually use that and extend on that and build.
That sounds, I mean, it just, the first thing it made me think of was this idea of retroactive public goods funding, where like some ecosystem entity could basically come in and put a floor in place for some NFTs. Be like, anyone who contributed to this public goods project got an NFT at some point in the past, and now we're just gonna like put a floor there. And I mean, this is its own rabbit hole, but you could totally implement some of those things very easily using this protocol.
Yeah, another thing that I really get excited about is you can combine criteria-based and partial fills with gasless listing. If you think about the way that the OpenSea shared storefront works, by default, the OpenSea shared storefront already gives a user's proxy, their OpenSea proxy, approvals. A side note, no user proxies anymore, which is going to be a big win, not having to deploy your own contract just to list. So you can buy from the shared storefront without having to pay gas to bootstrap what's going on. And then it does lazy minting. So you actually buy something that's only once it gets transferred that it triggers a mint. Now you can have NFT creators actually deploy their own contract and do the same kind of thing, then sign a single order. And that order now can be shared with marketplaces like OpenSea, and you can effectively do a primary sale directly through OpenSea and not have to go to a sketchy mint site and approve some new token. It's just right out of the box. You have a way to run a primary sale and have it populate directly in other marketplaces by saying, oh, I'm just going to sell 10,000 NFTs. You can take any NFT and purchase it, and you just fulfill the order, and as part of the order fulfillment, there's a token transfer hook that
mints it.
Yeah.
Wow, interesting.
So that's the kind of thing that I'm excited to see people build.
Yeah.
Like,
so primary
yeah.
issuance could just be, it's kind of lazy primary issuance where you say that this is what they're going to look like. This is, this is the functionality they give. This is what we want as a consideration to consider these orders fulfilled. And then whenever a single one of those orders is fulfilled, then that hook actually like mints the NFT for the first time.
Yeah, it would basically be like, in order to mint this NFT, you just have to buy it from the creator via Seaport.
Right.
Using this, there's this single standing, partially fulfillable criteria-based bid, and I can just pick one and buy it. And
yeah,
and that's how you mint. And you can display exactly what's being minted. I think it will really work well for membership pass type mints, and like if you have an 1155 or something like that, it's that's where it would be really cool.
Totally. So yeah, I feel like we've probably covered the different nooks and crannies of the protocol, though there seems to be more to it every time I think we have it. so maybe
there's a lot. Yeah. But it's also, it's great that, like, I love this longer format where we can actually get into the weeds.
Totally.
And actually outline a pretty comprehensive summary of what's going on. What I will also say is that if you have questions about how other things work or ideas of how to improve on this, we're all building this together at this point. Like, this is now very much a community endeavor, and it's been really awesome to see how many people have just jumped right in. But join the convo on Twitter, open issues and pull requests on the repo, slide into
join the holy war between Viper and Solidity.
Like, yeah, this is something that we're all building together. I would not anticipate Seaport just being a static thing. Like, there's going to be new versions, and there's a path to support these new versions too via conduits. So we're all building this together, and this is just the first step.
Yeah. So maybe as a last topic, zooming out of the architecture of the protocol and how it all works, do you have any ideas of just new types of things that people should be thinking about or building on top of this? And things that, don't necessarily make sense, like just funky or like weird little ideas, just directions that might be interesting to explore.
Yeah. So as I mentioned earlier, zones are being slept on. I would love to see more exploration around what could be done with zones. Like the primary sale thing that we were talking about. Have a zone that implements a whitelist based on you submit a proof that you're in a Merkle group. That's a pretty awesome way to run a primary sale, especially that doesn't add bloat to the contract itself, because you put all of that logic in the zone. And you can reuse zones across different projects too, if there's like a shared updatable whitelist.
Yeah.
For different projects. The zone stuff, seriously, sky's the limit. That is like the fulcrum for extensibility that people should be exploring and thinking about. Another thing is, if you have an idea for like an in-game marketplace, a collection-specific marketplace, a marketplace that's geared around power users or a particular user segment or collection, or you name it, I would strongly consider looking into Seaport and exploring leveraging it, because even if you're not interested in all of the features, there's almost certainly a way to adapt it to do what you need. just getting your head around the mental models of the way that offer and consideration works. It's very expressive and flexible in that manner, and you'll benefit from all of the tooling and the community
and the liquidity, right?
Yeah, and that liquidity then can be fulfilled outside of your marketplace. You can originate it on your marketplace. You can show liquidity from other marketplaces on your marketplace, and you can do that in a way that's way easier to wrap your head around. It's going to cost a lot less gas, and ultimately is going to make for a more decentralized and user-centric model where users remain in control of their own assets, but also can transact in a way that you don't have to trust the other party. There's this mediation layer that we've all applied the various learnings from various pain points and built a foundational layer that is robust and flexible and composable. That's where I see this going, and I'm really excited to see what people build.
Yeah, me too.
Yeah, and I will have more updates on the Seaport front. We're just getting started here.
Just getting started.
Thanks, Tina.